Okay, good afternoon, everyone. I'm Darren. Today, I'll be representing my team to present to you the case of using AI for food waste. So these are my wonderful teammates who unfortunately can't be here today. So yeah, to get things started. So you think about food waste, many may not know that it's actually the third world largest contributor to climate change, but it also accounts for 6% of a global greenhouse gas emission. And for a small nation like ours, the problem goes beyond that. It's also about food security, especially when 90% of our food is being imported. So the good news is we can use AI to help to solve this problem. Right, but before I share detail of how, allow me to introduce this fictional character, Auntie Pao. So Auntie Pao is a new bread shop owner, and like many new business food establishment owner, she has to answer this question as accurate as possible to run her business successfully. And that question is, how much food should I prepare? Or in her case, how much bread should she make? Because she's the new bread shop owner, she have no basis to start off with. So here's what she did. She based it off the amount of bread she had to sell to break even. So on the first day, she prepared 1,000 bread. And by noon, everything got sold out. So that's great. But there's lots of opportunity there because everything got sold out by noon. So the next day, she prepared 1,500 pieces of bread, but only sold out 850, resulting tons of food waste. So why is there such a big differences between just two sequential days? It could be because of the day of the week or because it was a rainy day. The thing is, with just 2 days of data, it's hard to tell. So here's what she did. She went through a series of trial and error, and finally, just when she thought she got an optimal amount, then came the holiday season, which threw all her forecasts wrong again. And she isn't alone in this journey. In Singapore, there are a total of 8,000 F&B establishments, and 28% of them are being replaced every single year. Even big companies still struggle to make accurate forecasts. Can you just imagine how much food is being wasted through this try and error learning phase? So currently, there are existing solutions that can be categorized under these two main categories, food waste audit and demand-based prediction. Food waste audit is pretty interesting. What it does is basically install cameras or smart bins to analyze the food that usually consumers don't eat. So it's actually a viable approach and have helped to reduce food waste by 30%. But it has a limitation. Firstly, it can be expensive to install smart bin all across all the different F&B establishments or even cameras. And it is unable to account for any external or seasonal variables that may affect consumer behavior. And lastly, it's using information on food that has already been wasted. So why not we stop it at the source? So that's when we look into demand-based prediction. But it has its limitation as well. Small store owner like the bread shop, right, will never earn enough to justify the cost of hiring a team of data scientists. And they may never collect enough data to create any model that can be useful. So how then we let them tap on the power of AI? One way is to make them work together, pull their resources together, hire a team of data scientists, and pull their data together. But there's one main problem. They might not want to do so because they fear that their sensitive data will be leaked to their competitors. So how can we then create a model that allow them to work together collaboratively? That's why we tap into the world of federated learning. So federated learning is a way of, is a decentralized way of training a model. So we start off with a global model. So what it does is instantialize the model in the local model. So at step 2, each participants will then train the model locally. Once the training is done, you send the parameters, so not the data, to the server, and then some sort of aggregation is done to consolidate the learning across all participants. So this learning is then passed on to the global model to update, and then the whole step 1 to 5 gets repeated over again. So these whole steps will get repeated over and over again until a desirable level of accuracy is being reached. So federated learning offers several compelling benefits. Number 1 is data privacy. Since the data never leave the participant's device, there's a sort of promise that there's a reduced risk of data leakage. And number 2, scalability. There's no limit on how many participants can actually join to partake in this initiative. And lastly, because of the ability to take on a diverse set of data across different food establishments, it can result in better model performance as compared to them training it themselves. So moving on to dataset construction, we propose two main categories. One is external data and one is store level data. So for external data, is there to capture consumer behavior for external event that may affect the way they consume. So for example, during recession, they might not want to spend as much in the high-end restaurant. And for store level attributes, we recommend the following. store rating, location, size, etc., those that may affect the number of customers that they can hold at any given point of time. Yeah, so as much as we see the potential of using federated learning to solve food waste, we are also realize and understand the difficulty of it. So that's why we recommend to take on an incremental approach towards this, starting off with number of transactions. So at the start, a food store owner can use number of transactions as a proxy to determine how much demand they may get for any given day, and even better allocate their manpower resources. So once we see this approach matures, we can then take incremental step towards item level prediction. So for the data set for our competition, it should comprise of different restaurants, at least 2 to 3 years of data at the start, and include all the variables that I mentioned earlier. So the evaluation matrix should comprise of not just the accuracy of the model, but also the risk of leaking the customer data. So we propose a combination of these two main categories. So starting with leakage risk, we propose using this hierarchical mutual information neural estimation, in short HMI. So what it does is basically it estimates the mutual information between the client data and the model parameters that's been sent to the global model. So that can be an indicator of how much risk is there whenever a client sends the weights to the global model. It can be combined with accuracy matrix like mean absolute scale area. In our use case, we recommended this because it is based on our target variable or transaction data, which can vary across different stores and different locations. This can help us to account for that. Further breaking down the forecast accuracy, the highest weightage should go to the normal day-to-day operation because that is the normal scenario. But we should also take in mind of those situations where either a new participant choose to participate in this initiative, or maybe even new stores in new locations with no historical data at all. So by combining these two metrics together, we can ensure that the solution developed for the competition is not only accurate, but without sacrificing the privacy concern that a store owner may have. So starting with moving on to the feasibility analysis, we break down into 2 main aspects: technological feasibility and business adoption feasibility. So starting with technological feasibility, because the federated learning is able to train for more diverse set of data and has a better ability to generalize, it has a reduced risk of being overfitting to a specific set of data, and also it solves the cold start problem for a new store location. And it has been proven to be useful in several other fields. So more commonly known, Google Keyboard needs keyword prediction, and also in healthcare where data are very, very sensitive. So they actually use federated learning to help to improve certain use case of AI in healthcare. And for business adoption, there are 3 compelling reasons why business will want to participate in this initiative. Number 1 is cost saving. With accurate demand prediction, they can then decide on how much food to order from their supplier, and then they can allocate manpower more efficiently. So this cost saving can then help them to give them a competitive advantage over those restaurants that actually do not participate. And because of the nature of federated learning, it has the privacy and data, privacy and security reasoning that will encourage them further to join and partake in this initiative. So to sum up, federated learning gives us the ability to revolutionize the way that we tackle food waste. And because of the way that it preserves privacy and without compromising of any of the accuracy, we can then benefit both the business and the food system. And with the power of collaborative AI, we can work together and make the world a better place. Thank you.